So thanks for coming today. I appreciate you guys coming first thing in the morning and maybe avoiding some of the deals you can get in the rooms there. But so we're going to get started here. So we're going to talk about the importance of catch and release fishing today. And I work with Stony Brook, and a couple of people here I work with are also here. So let's get started. So my name is Salty. Real name is Mike Fogg, but most people know me as Salty. I graduated from Stony Brook University in 2014, and I worked as a deckhand on the RV Seawolf for about 4 years, and then I moved over to the Frisk Lab in 2018. And I've been fortunate enough my whole life to sort of keep my professional and hobbies in one place. So I have to thank that old man up there. He's my late father, and sort of dragged me into this and gave me the disease that I cannot get rid of for the rest of my life. So what do we do at the Frisk Lab? So at the Frisk Lab, we are a fisheries ecology lab. So we're studying the ecological processes that affect exploited aquatic organisms. So things like overfishing that are affecting the local populations of fish here. And the way we do that is that we catch, tag, and track fishes along the East Coast. And so I have a large acoustic array, and I'm going to explain to you what that is in a minute, that I maintain here. And then another one of our projects at the lab here is we conduct a seasonal trawl survey for the New York DEC. It's about a four time a year trip. We go out and we do 30 trawls along the south shore of Long Island with an 80-foot trawl vessel. It's the RV Seawolf in Port Jefferson, if you guys haven't seen it. It's docked right there in Danfords. And it's a general population survey, so we'll scoop up whatever we get in a 20-minute trawl, and then we'll sort that catch, and we'll take it by species, and we'll weigh and measure every single fish that we get. And then that goes back to DEC, and then they can release like an annual report on how the fish are doing and where the fish are being caught. And then so with the students here, like Ashley, she collaborates with other researchers for some of their papers and their research projects to further their careers. And so at the lab, in the off season, like right now when we're not catching fish or doing anything, we're analyzing data, we're going over samples, and there's a lot more that we're doing back in the lab that's really boring work. But let's get to the fun stuff. So this isn't your typical sort of tagging. This is acoustic tagging. So the way this works, instead of putting a spaghetti tag on the top of the fish, this is actually a device that we implant into the fish. So it's a little electronic device we insert into the belly of the fish, and then we sew it back up. And then we have a device in the water that listens for it. So this is an acoustic receiver. We put this at the bottom of the ocean, and it sits there and it passively listens for the tags. So they're on the same frequency, like that diagram says. They're both listening for each other, and then it picks up the tag. So each tag has an individual ID, so like 1, 2, 3, 4, 5. So I know when I go back and see 1, 2, 3, 4, 5, that's a striped bass we caught 2 years ago, and we can see where it was and when it was detected. But the way we have to do that is we have to physically collect these back from the water in order to get the data. So that's one of the processes we have to go through. We have to hire divers to go out and pick them up each year to get the data back. So here's a map of what we have on Long Island. It requires a lot. So we have 136 of these things at the bottom of the ocean. And they're always out there listening, trying to pick up any fish. And then every 6 months, we have divers go out, and they'll pick up these receivers, they'll bring them back to me, and then I can bring them into the lab, connect to it on a computer, and it'll show me this disgusting Excel sheet with 1 million detections. And I'm not even kidding. It's up to 100,000, sometimes 1 million detections on there, and you got to filter it out and figure out who's who at this station. So it covers the vast shore of Long Island, but it doesn't cover everything. So we're going to get into some techniques that we go through. So first off, we're going to go through our target species. So what are we tagging? And we're going to target commercially and recreationally important species, such as bluefish, black sea bass, false albacore, of course the striped bass, summer flounder, and weakfish. And then on the shark side, we're also catching and tagging sharks. So we're tagging some black tips that we get occasionally up here. We're tagging duskies, sand tigers, sandbars, and thresher sharks. And occasionally, every now and then, we'll get a white shark. And we got about 4 of those so far. And a couple more we've caught on the trawl, but we're focusing on rod and reel fishing today to kind of see how catch and release really is effective. So what do we use? You guys are out there fishing all the time wondering, maybe we might be using something different. No, we're using the same stuff. We're using typical average setup here. We use the Lamy Glass Black series. It's like a 7-foot, standard. We catch basically everything with it outside of the sharks. And I've even caught a couple of sharks on this rod, but they handle everything we need in a Daiwa BG 4000 with just 20-pound braid. And then for the lures and stuff, that's really the important part of this is I'm trying to stress the importance of using things like inline singles here. So I put inline singles on all of our top water lures and a couple of our plugs. And they come in packages like this. And you have to upsize them a little bit to what your treble hooks are, right? So this is I believe this is a 3 or 4.0 size treble. So to match that, you want to use like a 4 or 5.0 size inline single. That way, because the inline singles are a little bit smaller than what the size of the trebles would be. But these really, really help us in when you're catching the fish, it's not damaging them as much. So you're not getting trebles in the gill, you're not getting a second treble down in the gullet or anything like that, or it gets stuck in the eye. A lot of the times we just have one hook in, bring in the fish, unhook it, and then we can start our tagging process. And then as for lures and stuff, really it's just Lunker City, Gulp, Yozori, Spro. We're not going out and buying the $100 plugs these guys are selling or anything like that. We're just basic stuff. You don't need anything fancy. And then we'll get into it later, but really one of the most important things for us are these fish grippers here, and I'll explain why in just a few slides. So for these little tags, I'm talking about them, you guys haven't seen them yet, but let's take a look at them. So we're going to start with the smallest ones, and these are used for the smallest fishes. So this is what we call a V9 tag. This is what we use for finfish, so things like summer flounder, weakfish, and black sea bass. And this has a 2-year lifespan. So the tags don't last forever, but it does give us very good data when we do have them. So what they do is these will just give us basic time and location. So when the receiver detects it, we'll just get, okay, this was 4 o'clock in the morning on Sunday the 22nd. So then I'll know where it was and when it was. And then, as you can see in the picture, we insert the tag in the belly of the fluke there where the organs are, or just in the ventral part there of the weakfish and or black sea bass. And then we go up another size. So these are the V13s. These are what we use for striped bass, false albacore, and bluefish. Now these give us some more data. Instead of just giving us time and location, we also get acceleration and depth. So when the fish is detected at the receiver, we'll also see how deep it was in the water and how fast it was going, which is pretty cool. So you can kind of extrapolate some data like that, like feeding activity or just transiting activity on top of everything else we get. Now these also have a 2-year lifespan, but that comes with the cost because it's also giving us that time and or that acceleration and depth data. So the third type, the big honka-chonkas, these are called the V16s. These go in the sharks. These will go in the sharks, sturgeon, and maybe bluefin tuna. But these have a 10-year lifespan. Now these give us time and location, but also gives us temperature and acceleration. And similar to the other fish, we'll insert this just above the anal fin here after we do our surgery. And then we'll sew them back up, and these will give us 10 years of data. And you'll see we do get 10 years of data sometimes, and it's really, really cool when you get that full long track to see where they're going. So how's it all work? When we catch the fish, obviously it's a whole process. Instead of just you guys catching the fish, releasing it, we're going to catch the fish, we bring it on board, and then we have to do our whole tagging process. So first things first, we cover their eyes with a towel, a wet towel, so that calms them down. Usually when you do that, the fish will stop moving. And then we run water through their gills using a hose, with an onboard hose, or we have a portable pump that we have that pumps water through their gills slowly so that they're able to get oxygen and breathe while we're doing the whole process. We take genetic samples, so we take a fin clip, and then we'll also take scales from the animal. The scales will give us age, and then the fin clip can get us some genetic ID from maybe where the fish is from or stuff like that. And then we'll do a quick surgery. So as you can see, Ashley here is doing a surgery on the striped bass, so she's actually suturing it up with a little suture, and we'll just cut that off, and it degrades after like a year or something like that, and then it's all patched up. And that's where the tag's going in on the false albacore there. And one of the big things is a lot of the fish are pretty good at recovering, but some of the maximum recovery times we get are like 40 minutes. You can sit there hanging over the side, reviving these fish for 40 minutes, which is one of the things I would like to stress, because it's really important, you guys, when you're releasing the fish, if it doesn't look good, give it some time. Give it some time. It's really important. It's not dead, but if you give it some time to get some water through its gills, run the boat a little bit, you'll see they will come back every time. We've done it with fish we thought were dead. We've done it with fish that people dropped that were dead, quote unquote dead, and we brought them back to life. So here's just some pictures we have. So obviously weak fish on the left, winter flounder in the middle, the white whale, but same thing as the summer flounder. And then bluefish and false albacore, all getting tags in them for 2 years of data, up to 3. But let's move on to the big boys. Actually, sorry, one more slide. So this is the important part. I actually brought it with me today. This is what we call the throw and tow. It's just your fish grippers, right? But we have a 10-foot line attached to it. And what we do is we tie this line off to the cleat. And if you have a fish that's not doing well, say you guys are out there and there's a big blitz, you got hundreds of fish all around the boat, you can't keep calm, you don't want to sit there hanging over the side, right? But you want to get this fish alive. So what you can do, close the grippers on the fish, let them go behind the boat. If you have a good drift, that actually just keeps water through their gills and they're fine. And just let them go for as long as you can. If you can, bump the boat in gear. Just bump it in, bump it out, bump it in, bump it out, bump it in, bump it out. And once you see that fish start swimming, he'll upright himself. And then once you see that, you can bring him in, unlock, and then push them, and they'll kick away just fine. We've done this time and time again, and it's really shocking how well it works. So that's one of the things I suggest for you guys if you're ever running into these situations. But like I said, let's move on to the big boys, the sharks. This is one of the more fun things we do. Not that the other thing isn't fun, but you get to play with big sharks, which is fun. So you catch the fish. It's a longer fight sometimes, can be up to 4.5 hours. But some of the more average sharks we get here are more likely 10 to 15 minutes. We bring them to the boat, and then we have a person that wires it. You secure the head, and then we have another person come in behind. You can see Allegra there is grabbing the tail rope, so it's just a big loop that usually has like a weight on it or something. You come up around the tail, you secure it, so you have both ends of the fish secured. You can tie them off to a forward cleat and a stern cleat, and that'll keep the fish just like that mako on the stern there from moving, and then you can start doing our workup. And obviously this is a little different. We can't bring the fish on board, so we got to do all of our work overboard. So our first thing is we do measurements. So we do a lot more measurements on the sharks than we do the finfish. So the finfish, we do total length, fork length, and then we do a girth. For the sharks, we do multiple girths, and then we do total length, fork length, and then pre-caudal length, which is just like right where the butt of the tail starts, basically. And this will give us like a good health indication of the animal. And on top of that, we also do, we do muscle samples, blood samples. We take a poop sample, and we also take a fin clip. And like I said before, that gives us more data to give us a health indication on the fish. So we can see, if there's mercury levels that are high in the animal, or we can see what sort of isotopes are in the meat, and then we can also get like genetic data from that as well. And then on top of that, we put a spaghetti tag on the back of the dorsal to ID the fish if it gets caught by anyone else. So once we're done with that top side, we're going to flip the shark over. And if you guys haven't heard of this, you're putting the shark to sleep, more or less. This is called tonic immobility. It sort of calms the shark down a little bit. So we can do our important work, which is putting in the tag. So once we have it flipped over, we have somebody stabilizing the fins here. So they hold the pectoral fins, and then one of us can do the surgery and put in the big tag. And usually this takes about 3 to 5 minutes, depends on the sea conditions, depends on how the animal's behaving. But we try and make it a pretty quick process, and we'll run a hose through their mouth sometimes if we're at a really, really stale drift. But a lot of the times when we have a good drift, water will be moving through. So here's just a nice picture. Maria, one of the students that we have, is putting the suture in the animal while I'm holding the back, and then our boat captain there, Charlie, is holding the wire to make sure the animal's still secure. So once we're done, we want to make sure the fish is released good. We're not going to just drop it into the water. We want to make sure they're moving and ready to go. See if this video works maybe. And you can see a nice strong kick there. Usually they're not happy. I wouldn't be either if I was just abducted and then thrown into the water with a couple of extra things on me or a couple of missing things. So let's go to the possibility of one of you guys catching one. What if you guys caught one of our fish, right? How are you going to know? One of the big things is they're going to have a spaghetti tag on the back, and the spaghetti tag is going to say, do not eat, internally tagged. And it'll have my boss's phone number on there, and if you could harass him by any chance, that would be great, and let him know that you caught one of our fish. One of the important things we need to know is the length, the weight, if you can get it, the location of where you caught it, and the time. That'll give us like another point in our data sections that can give us like just more data for planning our stuff. So, and one of the things we ask, you don't have to, it's your fish, you can do whatever you want with it, but please consider releasing it. This data is priceless for us. So if you catch a fish that has a tag in it, releasing it, we can get more data back from it if it's a healthy fish. Of course, it's your fish. You can keep it, do whatever you want. I'm not going to tell you how to live your life, but if you're going to, sorry, dry mouth. If you're going to contact my boss, please tell me what you caught it on. That's more important for me. I want to know. I want to get better at this. So let's go into some data. We're going to dive into a little bit of science, not too much. But this is sort of a graph that shows all of the fish that we've caught using rod and reel, right? So you can see obviously our biggest customer here is striped bass, then followed by summer flounder. We have 85 of those, 59 weakfish, and then 64 sandbar sharks, and then bluefish and black sea bass we have about 50 of, and then the rest of them are all kind of like 10s and below, just because we are either struggling catching them or it's not one of our like focus species. So that's sort of that, and the numbers are going to pop up again, so you don't have to remember this or anything. But so far, catch and release will define as a surviving fish if it's detected in our array. So right now, in total of the 795 fish that we've caught, 555 of them have been detected, which is 70%, and 240 of them have been not detected. So it gives us about a 30% maybe mortality rate, but there's a lot of factors to consider into that, which, an average catch and release mortality varies anywhere between 8 and 30%, depending on what fish you're looking at and what the study is. But this tagging process does induce a lot more stress into the fish than what you guys would be doing, right? You guys are just going to catch the fish, take a couple of photos, throw it back in the water. We're going to grab the fish. It's going to be like 5 to 10 minutes sometimes with the sharks. Sometimes it takes 15 minutes if it's giving us a hard time. So that may factor into why we're not detecting them, or sometimes they just swim out of the array. I'll go a little bit deeper into that later. But we try to focus on fish that are really healthy, that are looking good. We've hooked in a good spot. Right in the corner of the mouth is really what we're looking for, and that'll give us the best chance for the fish to survive. So looking by species, this all is like what we would expect. In fact, some of it's a little better than what I would expect personally. Striped bass do very well at an 83% detection rate. Weakfish and bluefish kind of surprised me in two opposite ways, where I thought bluefish would do very well, but they did a little bit less well than I thought they would at 73% detection rate. And then weakfish, we've detected 62%, which I thought they would have a really hard time when we're tagging them because they're a very fragile fish. But turns out we actually get a good return rate on those fish, which is very awesome. And we've gotten some good data back from that. We're going to get into sort of what all this means and where they're going, but we're going to kind of break it down by species just for a couple of slides. And some of the not so good results are things like black sea bass, summer flounder, and false albacore, where you don't get a very high detection rate. Now, some of the things to factor in here, so false albacore, we've only got 6 of them, right? So that's a very low number. But black sea bass and summer flounder, we've got over 50 of each species, and we're not detecting them as well. One of the things with black sea bass is they really don't move much. So if they're not directly in range of a receiver, if they're on some other structure, they're probably going to stay on that structure for a long time and just move offshore and onshore. Whereas summer flounder, they're on the bottom. And I'll kind of explain how they might not get detected in a couple of slides. But more or less, they're going to go under the receiver outside of its range of detection. And as for the sharks, they do excellent. We do get really, really good detection data back from them. The sandbars, which we have the most of, 92%, that's awesome. Duskies, we have 84%. That's a great number. And then sand tigers, we have 71%. So that's really great and kind of within the range of mortality we might expect. And then for white sharks, we've got 4, and every single one of them have been detected on the array. And then common threshers, we only have 6, so that's kind of skewed a little bit, but still in that range of like 67% detection rate. So why are some fish not seen, right? So obviously your first jump to is maybe the fish died, right? So it could have died from our procedure, it could have died from predation, it could have gotten caught shortly after. We don't know what happens, we just know that we don't see it, right? It might not pass by a receiver within that array, right? We've only got a very small bit of the south shore of Long Island covered. They can go anywhere. They can go around, they can go up through the rivers or anything like that. And just because it's not detected doesn't mean that it's dead. It might show up later. We get fish that we tag, don't see for a year, and then the next year it pops up like it was fine. So it's really hard to predict how things can go. But so they can swim, like I said, they can swim over or under the receiver. Like the diagram here, so this is the top, and the range, the cone of detection basically goes up and out like a triangle. So if the fish goes underneath, it's not going to detect it. Now, so the fish can go underneath, or if it swims too fast. So the way these tags work, I think I failed to explain that, was they have a random ping that goes off every 2 minutes, 3 minutes, or something like that. And that's when the receiver can pick it up. So if they swim faster than the ping would go off through that array, then it's not going to get detected, right? But usually it's programmed slow enough so that any fish would get detected. But things like false albacore might be a little too fast for the array. So let's just review the map real quick. So like I said, right, we've only got this short little portion here of Long Island in the long consideration there covered. They can go anywhere. They can go way out here. They can do anything they want and avoid the array. But we do have a good portion of the inshore bits covered. And so what we do with all of this is we can make maps. So when we get detections back, we can sort of go by station and figure out, all right, this fish was here in September, and then October it moved over here. So this blue fish we tagged in 2021 in Great South Bay, right under the Fire Island Bridge. It was tagged on June 4th, 2021, and then it moves all the way up to Montauk, out into the Nantucket Sound, and then all the way back to Fire Island, and then shoots east in the middle of November, which is pretty cool. The bluefish have been returning really, really good data for us, so it's been really, really neat to see this. And then we move to the next year, the same fish, right, ID 51193. This same fish comes back in and avoids our array, right? So this is Montauk here. Avoids our array, and it shows up in Long Island Sound and then goes back out to the Nantucket Sound. Sort of that same general time frame, late October, maybe early November, and that's the last time we saw it. Until next year. So 2023, it comes right back up, and this is the Rockaway Inlet here. It stays inside Great South Bay, goes through Fire Island Bridge, and then either comes out Fire Island and goes wide to Montauk, or it stays inside the bay and avoids some of our receivers in the bay. So that's 3 years of data that we get back from one fish, which gives us a lot of good data to go through. So another bluefish that we tagged, so similar time, but following year, so June 4th, 2022, we tag it inside the bay, and then it moves from inside the bay, stays inside the bay. It's kind of hard to see the map there, and then pops all the way back on the, explain this incorrectly. In 2022, he was tagged, and then he shot right to the canyon. That's what happened. And then the following year, 2023, first detected, and this is like a blow up here. And then he moves inside the bay and then comes back in 2023. So we kind of get the point, but we're going to do one more bluefish, right? So these are 2 bluefish that are tagged at the same time, and we've named them Dandelion Ruby. These 2 fish were tagged at the exact same time in the exact same place, Moriches Inlet in 2022, and they go separate ways, right? So red is Ruby, yellow is Dandelion, and Ruby goes west out to Fire Island, and then shoots east the following year in July 3rd, and then Dandelion also shows up at the same time the following year, both detected on July 3rd, and they hang around in Montauk until November at the latest for Dandelion, but it's really neat to see these 2 fish that were tagged at the same time, probably in the same school, right? and then they come back together at the same exact time. I don't know what the odds of that are, but it's pretty cool to see that. And the following year, last year, we see dandelion goes coast-wide. So dandelion goes all the way to Lake Worth, Florida. So we have a bunch of detections sent from us from researchers in Florida that show us that this bluefish actually came down in the middle of February of 2024 all the way up into March, and he stays in that lagoon in Lake Worth, Florida for a month and a half, which is just incredible. It's one of the farthest swimming fish we've had at the lab. So, you know, that's really where this data comes in hand, is we get to see these crazy tracks that just one little fish goes. This is a fish that's probably only like 25, 26 inches or something like that. And they're going all the way down the coast. So let's change species. We'll go to weakfish and see what weakfish do. So this is a weakfish we tagged in May of 2021 in Great South Bay. And it jumps all the way up into Long Island Sound and then goes down to Montauk in 2021. So we see sort of a different movement pattern here with weakfish, and we're not going to really see them move large distances, but they're going to stay within Long Island and a little bit east. So this fish that we tagged in Riverhead sort of jumps out in Peconics and then out into the Sound and then shoots way east, which is not what we would expect in December. So get some really interesting moves there. And then the following year, that same fish comes back into the Peconics, moves around Gardiner's Island, or Shelter Island, sorry, and we get the last detection there in June of 2023. So different weakfish, but same spot tagged at the same day, right? So similar to those last two bluefish that we tagged, and we get sort of a similar movement pattern again, right? So it goes up and around into Long Island Sound. And I believe, yep, the following year, same fish. Now it does a similar movement at a similar time, right? So it comes in from Montauk on April and then comes around in Shelter Island there. So like I said, same fish, different movement patterns. If I jump back, right, tagged, same, or the day after actually, but same similar movement patterns. So let's move on. Everyone's favorite here, striped bass. This is one of the first striped bass we ever tagged with these acoustic tags, and we got some excellent data. And this was actually the first trip that I ever went out with Captain Jim Miller here. His son caught this nice striped bass. It was about 37 inches long, and so we got to see a full track, a full spawning track, actually, all the way up the Hudson River and back and out, which is absolutely awesome. So we tagged it here. Fire Island, comes back to the Rockaways, shoots east to Fire Island, and then it leaves in 2021. And then 2022, first detection up in the Hudson River, exactly when you would expect it, right in the middle of April. That's where these big girls are coming to spawn. Goes all the way up the river. See how far that is? That's awesome how far these fish go. Then comes all the way back out to Montauk, shoots all the way down the coast for a nice migration path. And then the last time we see him is right in the Rockaways in the middle of December. Does a little southern movement there, comes back. So it's just some really incredible data that we get back from these fish. Now that same fish comes back the next year, and it does a nice east or west-east movement, comes in March, and then last detection is in October. Swims right along the shore, so that's 2 years of data. That fish is 37, and then probably almost in the mid-40s at this point now. So real nice fish, and glad to see our first slew of fish that we tagged really 5 years ago, or 3 years ago, sorry, still kicking. So same day, same exact day, tagged another big fish. This one was 102 centimeters, so that ends up being somewhere around like 38 inches, something like that. And same pattern, right? So that one came in April 15th, 2022. This one comes in April 19th, 2022. Same, goes all the way up the Hudson, comes all the way back, probably spawns up there, and then shoots out to Montauk. And then last detection there is in 2022 of November. So that's great. But let's move on to some other fish, see what these other guys are doing. Some of the summer flounder that we do detect don't really get great data, but this is one of the best maps I could make from that data. So we tagged this guy up in Shinnecock in August 30th, and then moved all the way west to Fire Island in a 3-month span, more or less. Not the greatest map comparing to the other guys, but it's cool to see a little flat guy go that far. This was, I believe it was like an 18, 17-inch fish. And similar, another fish. So this is sort of what I was talking about, right? So I said sometimes we'll tag a fish, we won't see it for a year, and then it'll come back the following year. So we tagged this fish in 2021, didn't see it for a full year, and then it suddenly shows up in May of 2023, and then comes all the way in the bay. So when they're not detected, they're not dead. They just might not be coming in where we expect them. So what about those albies? These albies are a struggle for us, but we got 2 to get detected, and this is what we got from them. So one of the ones we tagged in 2023, we only have like 1 movement line from it. Really not the greatest, but it's something. So it shows that we are detecting them. They're not swimming that fast when they are getting detected. But the other one goes all the way to the Florida Keys. Goes all the way down the coast. This is the Keys right there. Tagged them in 2022, so we did get a detection in Montauk. So we tagged them all the way up in Montauk, and we got up on the array there when we first tagged them, and we didn't see anything. And then we got information back from one of the researchers in Florida that said that they had detected them and went all the way down to Florida. So that's just an incredible journey. What about black sea bass? Pretty much what we'd expect, right? So we tagged this one in Montauk, kind of just went in the line and went back. Better than nothing. So it's nice to see them alive. But let's see what some of these sharks do, because some of these sharks do some big movements. So we're going to start with the sandbars, and this is what I'm talking about, long data sets, right? So these are 10-year tags, remember. So this fish is tagged in 2018. We're talking almost 7 years now. So this fish first tagged in July in just off of Fire Island there, and then you can catch its southern migration in 2018, and then similar thing in 2019. We kind of catch it up in the Carolinas coming down, right? So this is Long Island there, and this is the Carolinas here, coming down to Florida. And then similar pattern in 2020. We get it all the way out in Montauk, and then comes all the way down to Florida in January of 2020. And then we keep going. So we keep catching this fish, same fish, 12726, not catching it, but catching it on the array. And it's that same similar pattern. We get it up in late September, and then comes all the way down in March. And then 2022, 2023, I think you kind of get the picture, but we're catching these fish over and over and over again on the array, and it's great to see that. What about another sandbar? Do we get something different? So similar concept, tagged in 2018, but we get some inner array movement. So it comes out in August, goes all the way along the array, and then comes all the way back down to Hatteras in December 30th. And then the following year, we can see it go from Hatteras all the way back up. It goes straight to Montauk, and then moves its way east down to Jersey in August. So we'll move on to 2020. We just get a smaller picture this time. Sometimes they're not detected along every array, but you can see it moves all the way along the south shore of Long Island, a nice east-west, west-east migration. And then the following 2 years, so we go 2021, we skip a year, right? So don't know what happened in 2022, but then 2023 shows up in Jersey, so it's not dead. They're just not swimming around the array sometimes. So let's try those sand tigers, those real lazy fish sitting up on the beach there, just hanging out. You don't see them very often. But these sand tigers that we catch and tag, they also do the same similar thing. They do these big coastwide movements up and down the coast. So we get them tagged in August of 2022, moves all the way down to Hatteras in October. And then the following year, in May, comes up from Jersey in June, hangs around Long Island for a couple of months, and then goes back down south. And then let's try those dusky sharks. So that's a similar shark to the sandbar sharks here. You guys might just call them brown sharks, but they are different species. So dusky shark, which we tagged in 2021, moves along the East Coast array, goes all the way down to Hatteras, and then the following 2 years, so we missed 2022, and 2023 comes from Hatteras up along the coast there, and then we catch him back in all the way up to July in 2023. And then same shark, but last year, so this is updated movement. We get it first detected up in the end of our array here, and then it does this back and forth, back and forth, back and forth from Fire Island to Jones for a couple of months, and then in September, probably shoots south back for another migration to the Carolinas. And then we're gonna go to one of our favorite fish here. This is a Thresher shark that one of our past graduate students got This is Lisa Crawford here. Dr. Lisa Crawford caught this large thresher back in 2018, and we've been tracking it since 2018, and it's made really nice coastwide migrations. So this one's going to look a little different. We're going to break it up by season, just so we're looking at something different here. So this is the fall, right? So we get fall detections in Montauk, Delaware, and then down to the Carolinas. And then we'll move to the winter detections. Obviously, they're going to come down, stay their winters in Florida. So Florida up at the Carolinas and the warmer waters there. There you can see this is the actual shark that we caught and tagged that day. So at the time, it was 230 centimeters, which works out to be about 7 foot total length, right? This is 6 or 7 years ago now at this point, right? So this fish still swimming up to 2022. Want to think about how big it might be. So this is our spring movement. You can see this sort of like upwards coming up the coast movement in 2022, or all the way up to 2022 in Jersey. And then we're going to move to the summer, which we'll expect to see them where? Up here. That's where they're going to spend their summers. Every year they're going to come up and we'll see them time and time again, Jersey up to Montauk. That's where these threshers are spending their times. And that's the full map. You know, you get the full long coast migration. And that's what we get from these guys. And then, so an updated time, this is 2023 and 2024. So 2023, we just catch them from Florida straight to the Rockaways, up and around. And then in 2024, we only got a couple of detections in Fire Island, but she's still kicking, so yeah. What's up?
Usually how far offshore?
When we're detecting them, this is up to 8 miles offshore sometimes. So now we're going to move on to the white shark. You know, we got those 4 white sharks, so let's see where these guys are going. And these guys are doing one of the biggest migrations of sharks that we're going to be seeing, obviously. So this is one that we tagged in 2020. Goes all the way up to Massachusetts and north, and then back down to Hatteras in 2020. And then we see now, the following years, it goes all the way up to Nova Scotia. So that's a big, big movement. That's going from the Carolinas to Nova Scotia, not even including us. So when these white sharks get bigger, they're actually not going to be spending a lot of time here in Long Island. They're going to be going up to Massachusetts, Cape Cod, you know, things like Nova Scotia, where their real prey is going to be, the seals, not something like just your regular fish here. This is another white shark we caught. We named him Charlie. Tagged it in July 31st of 2022. Made a nice coastal movement down to Florida, down to December, and then moved its way back up in 2023. And then since then, we have not seen Charlie. But again, same reason as to why. So this is a little different map. It breaks it up for sharks for you guys, and this is what we call a heat map. It shows like how many detections we get from each species. So the hotter it is, so like this is the more detections we get from them, the more detections we're getting in that area. Otherwise, we're not getting anything from here or here. So like with the sand tigers, you see them a lot in Fire Island there, and they're going to spend their time inshore, as we would expect. The sandbars and duskies, we get some similar data there that shows us they're spending kind of their time everywhere, not really in one place, just kind of cruising around inshore or offshore. And then the threshers, we get a lot of them here in the Rockaways, as we would expect, and then sort of don't get many in the middle of the array, but most of it is all offshore. So what are some of the takeaways here? This is a little graphic I took from New York DEC, but it gets across most of the points. You know, we want to minimize the time for that fish out of the water. And so if you're going to take a picture, take a quick picture. You know, when you're holding the fish, support the belly. If it's like a fin fish, if it's a shark, you know, take a picture in the water. Don't take it out. Obviously, that's state law. You cannot take the shark out of the water, so you have to release it from the water. Have your hands wet when you're holding the fish. Use inline singles if you can. Crush the barbs on trebles if you can. That really helps the fish survive. And, you know, don't snap a photo if you really have to. But from here you can see catch and release works. You know, I show we time and time again can detect these fish even after what we put them through, which is a lot more than what you guys would. Right, minimize time out of the water, minimize handling time. They need that slime on them. That's a protective coating for them. Practice proper revival techniques. Like I said, this throw and tow that I showed you guys, this is very important for like striped bass and stuff like that to keep them revived. Even if you think they're dead, they're not. They can come back. So inline singles and crush the barbs. And I'd like to thank you guys for coming. If you guys have any questions, I'm happy to take them. Yeah, so we stay here in Long Island. We charter a couple of captains here. Jim's one of them, mostly out of Babylon and Fire Island. We have a couple of school vessels that we use that we take out of Southampton, or we trailer out to like the Rockaways or something like that sometimes. But yeah, all these fish are caught locally. These aren't like I'm traveling around for. So the students are using this data for their PhDs, their masters. They're using it as research to support their thesis and defenses for their degrees.
You mentioned before that you take fin and scale samples for age, especially as it relates to like striped bass. Are you seeing less and less young fish?
Yeah, so if you guys have not seen what's been released recently, there is a alarmingly low Young of the Year survey from the Chesapeake River and also the Hudson River, which is showing basically 0 juvenile fish for striped bass. So if you haven't noticed, all the fish we're catching here are big. There's a lot of them. That's great. But where are the small fish, right? So you look at these surveys that the DEC, the states are doing, they're basically catching almost none. It's similar to what the crash was back in 2000 or in the 80s or 90s. So it's pretty alarming, and yeah, we are not tagging a lot of small fish. When we started, we had, some slot size, under slot fish, but, since then it's all been large fish.
When we perform the picture release, sometimes the hook is deep inside the mouth of the So should we just cut a line or just pull out?
So it's kind of a situation you got to take at hand, right? So long as you're using like circle hooks with bait and stuff like that, they'll be fine. Usually it's in the corner of the mouth, but it does happen sometimes. We get gullet hooked fish, and trying to take the hook out can actually do more damage than it does good sometimes, because you're ripping the guts out and you're trying to take that hook out, which could do more damage to their internal organs than it would, just cutting the line and releasing the fish.
Okay.
Yeah.
As to why the Young of the Year is 0?
Research that's figured out what's going on.
I believe, correct me if I'm wrong, I believe it's something to do with lack of forage for them. So like there's a gap between the spawning of the striped bass and the spawning of the food that they would be eating. So like small plankton or like small fishes and stuff like that. So like minnows and herring and stuff like that. It's like offset is what I've heard personally. I don't know if you have anything else to say, Ashley.
Yeah, people blame like water quality as well. It's like when a fish is first spawned, and then in that critical time period, it's like you need a really specific set of conditions for them to be successful, and the conditions are just not aligning in the current climate in the estuaries for a whole slew of reasons. But it's definitely an active area of research.
Yeah.
Like the abnormally cold winter that we're having now would be beneficial.
That is the hope.
Yeah, it's kind of the hope, because everything's been sort of accelerated the last few years. Been getting fish in almost early April now, and hopefully this kind of sets it back to more of what we would expect normally. But yeah, we'll see. What do you want?
Any talk of putting the rays in the Long Island Sound?
Yeah, so we're actually going to be starting up a project this year to put an array in the Long Island Sound. It's going to be on the west side, which is going to cover the entire stretch of Long Island Sound. I'll see if I can run back to the map real quick. But 8,000 clicks later. No, it's definitely up here somewhere. So we're actually going to be putting an array that goes, I think it stretches across here. So it'll cover that East River exit, basically, and we can see fish entering and exiting. Because otherwise, a lot of that data that I showed that's down to Florida, Carolinas, and stuff like that, those are other researchers that we're collaborating with that kind of send us, hey, we got your fish. Do you want to see what the data is? And we'll say, yeah, definitely. And then we can kind of plot the large movements from there.
How wide is the array, and what does it look like in the water? If I was driving by on a boat, is it something I have to look out for, or not to mess up the gear?
That's a great question. And I threw this in here and I forgot about it, so thank you for bringing this up. So like I said, so they're on the bottom, they've got a concrete mooring here, and on the surface, there's actually floats here. And we're kind of getting away from this because it's been a big waste of time for us, basically. the floats are there to mark for the divers, right? So the divers will see the floats, and then they just follow the line down, grab the receiver off of the mooring, and then they can put a new one on and bring it back for us. And what they're doing now is they're actually getting rid of this, and then they're just keeping everything on the bottom and no surface floats. So yeah, you might be seeing those. So there's, Fire Island, there's Jones, Rockaway, and Montauk. So if you're in any of those areas, you might see them all in one line, basically going out. And they're spread out by about like a mile or something like that. Oh, yeah.
Are you finding any benefit between, or like pro or con, between the fine scale array and the standardized space arrays?
Why are you asking me? That's a question for Ashley.
I've never asked her that.
Ask her. She knows. I don't know.
The fine scale is, they just ask different questions. Like the fine scale gives you like small scale movement, and you can look at like behavioral changes. But the bigger arrays, you can look at like seasonal changes, right? It's like the fine scale, like you just see it for like a few days.
So he's asking about this very specific array we have. So this is the regular arrays here off the South Shore. And then we have this array here, the wind farm off of Shinnecock. If you can't notice, there's like 20 dots there. Those are all receivers too. And this is what we call a fine scale array. And what it gives us, we can actually see a 3D location of the fish in the water using all of the devices together. They can detect each other, and then they detect the tag, and they can triangulate in the water where the fish is, which is kind of crazy. And I didn't really go over that, but it is sort of an interesting bit in here. And I also have videos for you guys if you guys want to watch. This is a deployment of what our blocks look like. So this is a 400-pound block of concrete, goes in the water with chain. Slow motion, we love that. There's the receiver, there's the float. And it goes all the way to the bottom. And then I've got a couple of release videos, which I've escaped from for some reason. So this is one of our favorite ones. This is a Albie that we released. It's going to do full speed. And that's sort of like your standard technique for releasing Albies, is you just kind of rocket them into the water, because that's how they breathe. They ram feed like that. Shift Control H. Do a slow motion shot for you guys. We can look at, this is sort of like once the bass is ready to go and we can release it. I grab it by the grippers. We have water flowing through the gills. Run my hand down to the tail, feel the tail kicking. Know it's ready to go. And give us a nice strong kick and get out of here. And then bluefish, not as exciting, but we'll show them anyways.
I'm just gonna let him go, so I can hold him back.
So you can kind of see that it's got the spaghetti tag on the fin there. You can see, maybe you can't. But these spring bluefish that we catch in May, when they're all stacked up on the flats there, they're kind of tired, they're thin, they've been moving up and down for a long time, so they're not as exciting to see.
Ready, you are.
See ya. What else we got in here? So this is this shows the throw and tow in motion, basically. Like I said, that long line to the grippers, and we just sort of bump it in gear, bump it out of gear. You can see the fish kicking there quite well, and you can actually fish while you're doing this, which is nice. And you can just kind of circle in one spot too. You don't have to go in a straight line. But yeah, it's a great way to revive fish if you want to keep fishing while there's fish all around you, or if you don't want to hang over the side of the boat and get a nice bruise on your ribs for the rest of the day. Kind of sucks. This is the sandbar release I already showed. Yeah, so thank you guys for coming. I don't know if you guys have any more questions, but enjoy the rest of the show.